Between 1956 and 1959, the world of time series has seen wonders. During this time, three very popular forecasting techniques were discovered, which we even use today. Because of their nature, these forecasting techniques are famously known as the exponential smoothing models. Let us start discussing the simplest among all these models that belongs to this family called the simple exponential smoothing. To understand this, let us bring back the weighted average model for forecasting, which we have discussed in the first video of the series. Choosing these weights may turn out to be a very difficult task to do. In most cases, you may want to give larger weights to the values which are nearer in the past and give smaller and smaller weights to the values which are farther in the past. In 1956, Robert Goodwell Brown addressed this problem with his new model, which is known as the simple exponential smoothing model. The reason it is called simple is because it was designed for time series which has got only levels, like this one. That is, a series which has got no trends and no seasonality. The simple exponential smoothing model says that the forecasted value of a time series at the next time point can be obtained using this equation. In this equation, dcap 2010 represents the forecasted value of the time series in the year 2010. dcap 2009 represents the forecasted value of the time series in the year 2009. D2009 represents the actual value of the time series in the year 2009, and alpha here is a smoothing parameter which ranges between 0 and 1. Now at the very first glance, this equation may not make a lot of sense to you. However, let me show you that the meaning of this equation is actually much simpler than it looks like right now. Well, if this is how we represent the forecasted value of 2010, then the forecasted value of 2009 can be represented in this way. That means we can write this equation in a way like this. Now, if we expand the second term in the LHS, then the equation will look like this. Well, this is not very hard to figure out at all. In the same way, now you can write dcap 2008 in this way and keep expanding this equation. And if you keep on doing this, then finally you will be able to see the equation in this form. This equation looks very much like the equation of the weighted average for forecasting. These quantities involving alpha can be seen as the weights. Now let us see how we may choose alpha to adjust these weights. If you choose a large value of alpha like 0.8, then you are giving a lot of importances to the last two observations in the series and giving near negligible importances to all the observations in the past. However, if you choose a smaller value of alpha like 0.2, then you end up giving at least some importances to the observations which are even at the fourth or fifth time point behind. In any cases, it is important to note that these weights decreases exponentially and hence the name exponential smoothing. Now, let us look at this table. You will be able to see that as you keep increasing the value of alpha beyond 0.5, you end up giving more and more importances to only a fewer observations in the past and give near zero importances to the observations beyond that. However, if you keep decreasing the value of alpha below 0.5, as you can see from this table, then you start to give some importances to the observations which are farther in the past, although you end up giving little importances to the observations which are nearer in the past. Here, I will leave you with a question. What kind of model will you get if you have an exponential smoothing model with a value of alpha equals to 1? Well, think about it. The answer is hidden in the first video of this series. In the next video, you will learn about how to fit a simple exponential smoothing model using R. Oh, by the way, if you're already liking the video, do not forget to support the channel by hitting the like and the subscribe buttons. See you in the next video.